everyone. Welcome back to AWS Pi Day. I'm Jasmine Kiles, a manager of product management here at AWS, and I'm joined here with my co-host, Adrian. Adrian, who are you?
Hi. I don't know who I am today, but I think the lower third says I am a principal partner enterprise architect here.
It actually doesn't. It says AWS OnAir.
Well, it should say something else, but we'll go with that. I'm an enterprise architect here at AWS. I've been here for a little under 9 years at this point, but we have somebody that's our guest that's been here a lot longer than I have. So, John, would you mind saying who you are, what you work on, and your favorite type of pie?
My favorite type of pie, huh? So I am John Handler. I'm a senior principal solutions architect. I have been with AWS for 15 years. I've focused on all of our search technologies throughout that whole time. I think my favorite type of pie, I'd go pecan. I kind of like a pecan pie.
A question, so, do you want the pecans smoked, or do you just want them like a little crispy, or do you want them natural?
Yeah, I love a little smoky flavor in the pecan that balances the sweet from all that goop.
Yeah.
So.
Do you like it when your pecan pie is like runny, or you want it to be like super firm?
No, firm. Okay. Definitely firm.
All right. We can debate about that.
All right.
There's no debate.
But we're not going to do that today. So what are we going to talk about today, John?
Yeah, today we're going to talk about search. And I'm curious, when's the last time anybody used a search engine? Jasmine, Adrian?
Like in the last 30 seconds.
Like in the last 30 seconds.
I was searching Pi Day traditions when I asked the chat. So chat, we're still here with you. I want to know your favorite Pi Day traditions, but I asked the search engine to tell me about Pi Day traditions.
There you go. And, I have a graphic that I'd love to show that hopefully captures kind of some of the normal way that we engaged with search until just very recently. So you come with some kind of query, you have some information need, there's something that you want to find. You have a few words, you have a text box, you can enter some text. You hit enter. Hopefully the search engine comes back with the results that you're looking for. Quite often it doesn't. And if you don't like the results, what you have to do is then try some different words, right? And maybe you get frustrated, and maybe you give up, and maybe you say, I hate search technology. Well, hopefully not, but this is the usual way that we do search, and it's really based on the search engine matching the words that you type, and sometimes we have left navigation where you can click into filters and do things like that, but matching that information against the words that are in the product descriptions, the product titles, if you're on an e-commerce kind of website, and for other kinds of searches, matches those kinds of things.
Okay.
So let's talk a little bit about OpenSearch, and let's talk a little bit about search engines.
Okay.
So OpenSearch is a fully open source Apache v2 licensed search engine, log analytics and observability suite, and a vector database.
Okay.
Fundamentally, what is a search engine? A search engine, I take my products, I take my catalog of items that I want to be retrievable, I format them as JSON, I use the REST API to send them to OpenSearch, and OpenSearch then indexes all of the text, all of the parts of that data, so that then I can run a query to go retrieve that data. It's very much like a database solution. In fact, a search engine sits in the databases world.
Okay. Makes sense.
So now with our advanced foundation models, our large language models, we're able to take that text and expand those terms to capture the context, the word context around them, and create these large dimensional vectors that place all of that data into a space where things that are like one another are near one another. So once I have my data coded as vectors, I can take a query and code it as a vector and match within that space to bring back similar or related items. And really that's the core of semantic search. That's the advancement that search engines have seen in the last few years. So when I use OpenSearch, it's more that I have my information goal, I maybe specify it with some words, and then I send that to my vector, my large language model to code it. I do the matching that way and retrieve. And in that way, a query like shoes for the beach, where I might match shoes, but I probably wouldn't match beach, that context of beach comes in, and beach shoes then become higher ranked in the results, and I'm able to match them better. So that's the first kind of shift that we've seen. The second is that, often you don't want to just type words. You really want to be able to have a conversation. It's almost like you want to go to the store and you want to talk to a representative there and say, I'm going to the beach. It's going to be 150 degrees. I need some really nice soft shoes that I can go and play on the beach, and then engage in a dialogue. Large language models, foundation models, and AI agents are providing the capabilities for us to be able to have those conversations. Fundamentally, what we do is you take all of your data, you encode it as vectors, you bring it to OpenSearch service. You write a chat application or an AI agent-driven application that takes a user question, goes and retrieves relevant items from the catalog of items, and then uses those as part of the prompt for the foundation model, so the foundation model can generate more accurate and relevant responses to the user's question, right?
Okay.
So this is the second kind of shift that we're seeing in search and how people search. So we have a demo that we can get to just to kind of see it in action.
Yeah, I've got to say, John, that's got to be one of the better, like, contextual and all-up explanations of how search works that I've ever heard.
Well, thank you for that. If you are interested, we're going to drop a couple of links.
Okay.
One of those is, I did write this out in some longer format, so if folks are interested, you can go to the O'Reilly Learning platform and you can go download the report there. Also, everything I'm going to demo is available as a hands-on lab.
Oh, okay.
And we'll drop the link for that. It's self-guided, should cost just a few dollars. You'll be able to build exactly what I'm demoing here today.
All right, cool. Let's jump into it.
Let's jump into it. All right, so I have what is probably very recognizable as a search interface. I have my search box. This is a set of product data that is shoes and apparel, primarily. So we're going to search for shoes for the beach. And we're going to use the old style search here.
Okay.
We're just going to match words, right? So if I go and search for shoes for the beach, you can see...
I'm not wearing these to the beach.
No, those don't seem like particularly appropriate shoes to put on if you're going to the beach.
Not even for a wedding.
Yep. You can see we've highlighted here the matches, the word matches. Primarily, this first result we're seeing is a lot of matches to shoes. But again, beach, the context, the reason that I'm searching is not in the words there. We can look at some other ones. Again, these are shoes. They're not particularly suited for walking around on the beach.
Okay.
These are definitely not suited for walking around on the beach.
I mean, you could do it, but it's not going to be well. I mean,
maybe if you were going to a beach wedding, you might want to wear those, but...
AM in the chat said maybe to Galveston. You need to wear some of those other shoes.
Yeah, maybe. Absolutely. So this is, again, the keyword-based word-to-word matching that most search engines do and have done for many, many years. Now I'm going to switch over, and I'm going to run this as a vector query. So again, we've encoded the titles and descriptions of all of the products in the catalog as vectors.
Okay.
And they are in a large multi-dimensional vector space. I'm then, the application is then going to code my query, shoes for the beach, into that same vector space and provide retrieval based on that. And what we'll see is that, again, that beach context comes in because of the correlation of shoes and beach in a lot of the products that are going to come out. So let's go ahead and run that one. Oh,
John, while this is running, I'm curious to know, what strategies would enable the efficient scaling of vector operations?
Yeah. So there are a lot of parameters and hyperparameters that you can use in creating the vectors, and a lot of parameters and hyperparameters that you can use in storing and retrieving the vectors.
Okay.
And generally speaking, you can trade off the cost of the solution, the accuracy of the retrieval, and the latency of the retrieval.
Okay.
So as you tweak and tune those hyperparameters, things like how many dimensions is your model producing? The the higher the dimensionality, the more cost that you'll drive ultimately to store and retrieve those vectors.
It's like the old analogy of choose three. You have three options: fast, cheap, and good. And you get to pick two, and you make your trade-offs.
It's exactly that. It's exactly that. And with Open Search Service, we do provide a lot of means for number one, connecting to external models, things like Amazon Bedrock, Amazon SageMaker, to do that vector coding portion of the work.
Yeah.
And we also provide a lot of levers and ways of scaling within OpenSearch Service. OpenSearch Service has a managed clusters deployment where you select hardware and we go deploy and run that hardware for you.
Okay.
And it has a serverless option that provides a vector database as well, where we do the scaling. You just send us those vectors.
Okay. That's very interesting. We're going back to the traditional search. Someone in the chat said, would specifying beach earlier than shoes have the beach being the primary focus, so to speak?
So, excellent question. Generally, search engines work as bag of words matching. So, generally speaking, order is not important. Now, search engines do store things like positional information of terms so that you can type something like a double quoted phrase and get a result that keeps the words together as a phrase. So I wonder if here I'm going to go off script here, gang. Let's go ahead and try.
We'll do it live.
Let's go and see how good or bad this is. Let's try beach shoes.
You mentioned something in there about bag of words. I too can be described as a bag of words if you ask AM.
Yeah, beach shoes is not actually doing much better. It does shift these shoes, the formal shoes, up higher. Okay. So again, it's really more about, is the term beach included on that item? So let's go ahead and run our vector search here, and let's put it back to shoes for the beach. All right, and what we'll see is, first result, groovy sandals. Sandals, good match for shoes for the beach. More sandals, bold fashion statement, these edgy sandals.
Much like numbers in the old world, those are definitely Roman in nature.
Yeah, these are a little bit Roman, absolutely.
A little bit.
So again, sort of to wrap up the interactive search part, or this strictly hit the search engine first workload, semantic search we call, we're able to bring in the context of beach and shoes to be able to retrieve results that arguably I would wear to the beach.
Yeah.
I don't know about wearing those Roman style sandals to the beach, but
you could minimize the amount of sand,
Yeah, I could, but as far as fashion goes, it's all Greek to me anyway. But I digress. John, this is pretty helpful to help folks in chat as well as anybody following along at home in being able to contextualize what is going on in the background when they go and interact with the search engine. So it looks like you're clocking something out, and we're going to continue on with the demo. So curious on where we're going now.
Yeah. So number one, yes, this is absolutely something that you can use for your data. Amazon OpenSearch Service provides you the capability to format any data that you like, whether it's your enterprise data repository, whether it's CRM kind of data, whether it is call center data. All of those things you can format and send to OpenSearch, and OpenSearch provides that core search experience on top of those. So we're going to shift now, and again, as I said in the beginning, we have two fundamental areas where we're seeing changes in how people interact with technology. And the second one is an expectation of, or a desire for having a conversation about the thing that you're looking for. So in this example code, we have a AI agent-driven shopping assistant.
Okay.
And AI agents are, again, a new kind of technology. This one is powered by Claude Sonnet version 3 that performs reasoning on the behalf of, from the prompt to come to a good answer.
Okay.
Right? So there's an AI agent in the back end here. We're going to ask it a question, show me shoes for the beach. The agent is now doing all kinds of thinking. It has 7 or so actions that it can perform, including going and retrieving items from the product catalog.
Okay.
So it can generate an image if it doesn't find anything in the product catalog. I think that's happening now because that takes a little bit longer. And then use that image as part of a multimodal search where it's able to search both things.
Okay.
So yes, in this case, it says the image generated looks like a good representation. So it couldn't find anything for my query. But what it did was it generated an image, and then it used that image, or it's suggesting that image as something that it can use to search the catalog.
Okay.
And we have to think about the usual interaction. You go into a store, you say, well, I'm looking for shoes for the beach, and they bring out a pair of shoes and they show it to you, and they say, like, what about
Yeah.
these? Right?
Yeah, you go through the hemming and hawing, like, yeah, those are nice, but the holes are a little too big, and they're not going to let the water through. And
Right? So in this case, these are perhaps, so it's offering then to go search the catalog based on this. But I'm going to say, no, I want something that, I want some sandals. How about?
okay, yeah, that sounds
Okay.
pretty good. Chat, what do you think we should throw out there? What sort of curveball should we throw, John? We gotta make it good.
I quite like the ones that it generated. Those might be good where somewhere where it's, rocky, it's not quite sandy. I can protect my feet,
Those would be good for tubing
a
back
good
out,
river
Jasmine.
float. Yeah.
Mhm.
Yeah, so those are more of a water shoe
Yeah.
kind of experience where maybe I'm looking for sandals because I just want to go for a walk on the beach.
Right.
There you go.
So these are some
Oh.
images of sandals, right? So
Okay.
based on the image it generated of slip-on sandals with straps and soles, it's recommending me Birkenstocks and Skechers. Well, maybe those to me, I don't like Birkenstocks, I don't like Skechers. Maybe
Okay.
I want something, say, well, how about I don't like Skechers? Again, this is the kind of interaction that you would have in a store
Yeah,
with an actual agent.
Mhm.
Let me click go. All right. And while we do that, I'm just going to quick pop up. Well, it's a little
Oh.
bit dim, but we can see in the background the agent's reasoning here. User wants sandals specifically for the beach. I'm not sure whether it's too dim, but it can then make a function call, get relevant items for text. So
Okay.
then it is calling the search engine, trying to retrieve those items. It gets an output that includes a hat, which is wrong, right? And so it thinks, okay, it's not very relevant, showing hats instead of sandals.
Yeah.
Let's try a different approach to find a good. So then it's going to generate an image, right? It generates the image and comfortable slip-on sandals with straps and a rubber sole. Here's the generated image. It sends that off, and it gets relevant items for the image from the catalog. It then summarizes everything, runs a Lambda function in the background to summarize and provide me with the response.
Yeah.
Right. So again, this is all driven by the agent. It is employing OpenSearch Service as a search engine to pull results, but it's actually Sonnet is generating the kind of reasoning and the way that it goes about doing
Yeah.
this kind of searching.
This is really interesting, and I think you brought these concepts and made them very, simple. Like, we've started to hear these terms, and for people who are newer to this, like,
Sure.
you're like, I'm hearing RAG, and I'm hearing multimodal, and all of these things, and so
Sure.
to bring it here. So if someone's net new to this, or they've kind of started to dabble into it, how can they go and learn more?
Sure. Well, first thing, I absolutely recommend running our lab. Again, you'll get exactly this. I deployed this lab for this demo, right? So this is exactly what you'll get. You'll get a lot of background and good information about what it's doing and how it's doing it. Again, I'd point at the content, the link that we sent, the
Okay.
doc that I wrote
Yep.
should be a good place to start too.
Awesome.
Great. John, always a pleasure to talk shop with you. Thank you so much for helping make this a little more easy to access, really easy to contextualize and see how the sausage is made, so to speak.
Yeah.
Folks, hang tight with us. We've got another session coming up right
Adrian,
next.
we don't just have another session.
I was going to say, but please do it. Do it. Do it. Do
Hey,
it.
if you are watching this, you need to go share it with someone right now. You need to like it, thumbs up it, make sure everybody sees it because you don't want to miss what we have coming up next. We've got Jeff Barr and some special surprises for you right after this break, so stay tuned.